Now, as in every course section, I got a brand new project, just created a Go module with the Go mod init command. And I want to start with lists of data, with managing lists of data and what I mean with that. And for that, I'll add a lists.go file. And in there, as always, I'll add my main package and then also my main function because we'll still need that. Now, what do I mean when I say lists of data? Well, let's start in a different way. We did learn about that struct, where we maybe have a product, and hence we have our struct, and in there we then have a title for the product, and maybe an ID, and maybe a price, which is a float. That's what we saw before in the course. The struct concept or feature is a very useful feature because it allows you as a developer to group data together. We group a title, an ID, and a price together into one data package. And organizing data like this is super important because very often in your programs you have more complex pieces of data that you want to express. But in a nutshell, a struct is a data grouping mechanism. And we do group different kinds of data into one piece of data. A title, an ID, and a price are very different data pieces that are grouped together into one data piece. That's how you can think about a struct. Now, in some programs, actually, as it turns out in a lot of programs, you don't just need such kinds of data groups, but sometimes you also have similar pieces of data that need to be grouped together. And that might sound very abstract, so let me give you an example. What if we would be building a Go application that's dealing with some data analysis? And therefore, as part of this application, we might get various values. For example, some weather data, maybe some product prices, which we want to analyze. Doesn't matter. We get different pieces of data. Let's say different numbers. Now, they all express the same thing. For example, if we get temperature values, every number might express a temperature in Celsius or Fahrenheit. But we, of course, have different values. Now, if we work with such kind of data, where we have many values that describe the same thing but have different values, then a struct won't help us. We could, of course, create some struct temperature data like that, and in there have the temperature of day 1, which holds, let's say, a float. And then we have day 2, which holds a float. But doing it like this, solving this problem like this, would be very annoying. Because we have to know in advance how many days of data we want to have. And even if we do know that, we have to do a lot of typing to describe all those days, to set up all these day keys. So that's very annoying. It would lead to a lot of code and to code that's quite unreadable. And working with that kind of data would then also be a bit annoying throughout the application. That's why for such cases where we describe the same thing and we just have different values, we have a different kind of data structure built into Go. And we have this kind of data structure in basically every programming language out there. It's just a name that's different between all those languages. We have a so-called array. In Python, it would be called a list. In JavaScript, it's also called an array. And an array is a data structure that holds values, potentially different values, that kind of describe the same thing. Now let me show you how we create such an array. For that, I'll create a brand new variable that will hold my array. And let's say we want to work with a bunch of prices here. But of course, it's up to you. Here, I'll just go with some prices. And let's say that should in the end be a list of floating point values. So a list of floating point numbers that we want to store in this prices variable. Now, since it's a brand new variable, we'll use the $=sign operator to create it and set a value immediately. And now we can turn this into an array by using a special syntax. We want to have a list of floating point values, as I said, so I'll type float 32 or 64, doesn't matter. And then in front of that, we add square brackets. This is an important piece of syntax that tells Go that we don't want to create a single floating point value that should be stored in prices, but instead a list of floating point numbers. Now between those square brackets, we then have to tell Go how many values we want to store, and let's say that's 4. So we want to store 4 floating point values in a list of floating point values inside of prices. Now it's still not all. When using this syntax here and immediately assigning a concrete value to prices, which is what we do with this operator, we also have to let Go know which values should be stored in this array. And for that we add opening and closing curly braces here. Now here, between those curly braces, we can now enter the values that should be stored in this list. So something like 10.99, 9.99, 40, 5.99, and let's say 20.00, or just .0. This now creates an array, a list of 4 numbers, 4 floats that's stored in prices. And you can create arrays based on any kinds of values, not just floats. You can create an array of strings, of integers, even arrays of structs and other arrays, so-called nested arrays, are possible. But let's start simple. Let's take a look at what we created here by using the format package and calling the println function, to which I then pass prices. And now we're not using this struct anywhere, so therefore I'll get rid of that since it was only there for demo purposes anyways. Now with that array created, if we open that terminal here, if we run our module, we get that list of data output here. And that's how we can create such a list of data. And the key difference compared to a struct really is that all these values describe the same thing, a price. But of course we describe different prices, and hence we have a list of these different values that describe the same thing. And that's a fundamentally different idea than we had it with a struct. And different scenarios and use cases in your code simply require different solutions. Now let's take a closer look at this array thing and what we can do with it and how we can create it. Because here we only see one way of creating an array. We can also create an array by using the var keyword and then giving the variable any name of our choice. Let's say we have a couple of product names, so I'll choose product names here. And now I don't want to initialize it immediately, I just want to declare this variable and make it clear that it should contain an array as a value. So it's not a string, which would be a single value, but instead an array of strings. Same syntax as down there. Square brackets in front of the type of value that should be stored in that array. Now, when creating such an array, you also typically want to set a length for that array so that it's not an empty array which has no items at all. And you do that by adding that length, so the number of items that should be stored in that array between the square brackets. So we could use 4 again or 3. It really depends on how many items we want to store. Let's go with 4 here. With that, I'm creating this array, and if we now print that without assigning any values, if I print my product names like that, and we then open that terminal again, if we run our code, we see this. It's very important to note that the program doesn't crash or anything like that. Instead, the null value that's now set for product names is now simply an array with 4 empty slots. And that's what this in the end represents. Now, of course, we could set product names equal to an array now by, again, let's say creating an array like that, And then we could pick different names like a book and so on. And you also don't have to set all the names. If I just set one name and I run this program again, you see one name is set and the other slots are still left empty, so that's possible. But you also sometimes have the scenario that you want to set specific values. Let's say the second value in an array. Or you want to read a specific value instead of outputting the entire array. And therefore, that's another key mechanism that you need to know as a Go developer. How you can target individual values in an array so that you don't always have to set or read the entire array as we're currently doing it. Now for that, first of all, to get rid of those yellow squiggly lines, I'll merge this into one line here, like that. And then I want to show you that syntax for accessing individual items. Let's say we want to print the third price in the prices array. So here I want to print prices, but not the entire list, but just the third value. For that, we got a special notation that allows us to access a specific value in an array. We again use square brackets, but now not to create a new array, but instead after a variable name that holds an array to tell Go which specific item we want to access. For a struct, we used the dot notation, but for arrays, that's not available because arrays are not structs. Instead, for arrays, we use square brackets. And now we also don't have key names for those different values. I mean, where would those key names be? But instead, all those values have unique index values, which are automatically assigned. And the logic here is very simple. The index values always start at 0 for the first element. And that can be a gotcha. It's not 1 for the first element, but 0. So if you want to output the first element, you would write prices and then 0 between square brackets. So if you want to output the third element, we need which value here? 2, because we have 0, 1, 2. This has an index of 2. So that's how we get access to the third element. And that's just something to keep in mind. Thankfully, it's the same in most other programming languages that arrays or lists, or however that feature might be called there, start at index 0. So with that, if we save this and open our terminal, if we now run this program again, we see that 45.99 is being output. And that is how we can create arrays and how we can read single values from arrays. We can, of course, now also set single values. For example, if you want to set, let's say, the third product name, we did set the first one thus far. The other slots are left out empty. If we want to set the third one, we can set product names and then again target the third element, which still has an index of 2, and set this to a specific value, like a carpet. Now, on product names, we'll have the first value being set and the third value being set, and the second and fourth values will still be empty. But that's fine, that is something you can do. With that in place, if we run this program again, we output a book, then our empty blank slot, then a carpet, and then another blank slot in this array. That's how that works, and that's how you can work with arrays. But that's far from everything that you need to know about arrays and that you can do with arrays.